Find the equation of the perpendicular bisector between the points P, -6, -2, and Q, 6, 4. Okay, in order to do this, we're going to visualize the problem using this GeoGebra applet, which I will put in the notes of the video. So, here I have the point P, which is -6, -2, and here I have the point Q, which I can see is 6, 4. Now, the steps are as follows. First of all, you find the midpoint of this line, which in this case is going to be there, the point 0, 1. Then you have to find the gradient of PQ. And then you need to use your knowledge of perpendicular lines, because the perpendicular bisector has a gradient which is perpendicular. Basically, this gradient times this gradient must be equal to -1. And then to actually find the equation of the blue line here, this is what we are actually doing. It's called the perpendicular bisector. And then every point on this line is also equal distance from P and Q. It doesn't matter which point you take, the direct distance to P and Q will be the same. So the object is to calculate this equation of this line. Okay, so the steps are as follows, which as sort of explained in the GeoGebra applet. Find the coordinates of the midpoint M of PQ. The midpoint formula in coordinate geometry is x1 plus x2 over 2, comma y1 plus y2 over 2. Now it's a good idea to label underneath each of these. This one is x1, y1, and this one is x2, y2, and then do -6, which is x1, plus x2, which is 6, divided by 2, and then do -2 plus 4 divided by 2. This obviously gives you 0 over 2, and this is going to give you 2 over 2, which gives me an answer of 0, 1, which is the midpoint of that line PQ. Now we find the gradient of the line PQ. So the gradient formula is y2 minus y1 over x2 minus x1. So using the same ones, we're going to do 4 minus -2. So 4 minus -2, be careful of signs, divided by 6 minus -6. Okay, so that gives me 4 minus -2, which is 4 plus 2, which is 6, and then 6 minus -6, which is 6 plus 6, which is 12. It is also a good idea to simplify any fraction that you get and leave it as a fraction which is 1/2. Step number 3 is to find the gradient of the perpendicular of PQ. We call that MP. And then we know that MPQ is 1/2 from the previous part. Therefore, for perpendicular lines, the original gradient times the gradient of the perpendicular, which we're trying to find, is equal to -1. So the gradient of the original line is 1/2. So 1/2 times P1 is equal to -1, which means that the gradient of the perpendicular is going to be -1 times 2, which is -2. And the final step is now to find the equation of the line passing through the midpoint M, which we just found 0, 1, and the gradient, and has gradient MP, is equal to -2. So using the idea y minus y1 is equal to m times x minus x1, you note you can also use y is equal to mx plus c. So underneath this will be x1, y1, and this will be the gradient m. So substituting into here, we're going to get y minus y1, which is 1, is equal to m, which is -2, x minus 0. So that's going to give me y minus 1 is equal to -2x, and then y, add 1 to both sides, I'm going to get y is equal to -2x plus 1. So this is the form y is equal to mx plus c. There are alternative ways of writing this. So if I add 2x to both sides, I get 2x plus y is equal to 1, or I get 2x plus y minus 1 is equal to 0. These are all different formats. All of them would be correct. If we go back to the GeoGebra applet, we can see we have found the equation of this line. This is what we have actually done. If you are graphing this using some software, you have to make sure that your axes are equal aspect, otherwise they won't look like they are perpendicular to each other. Okay, I hope you've understood. This is a video that shows you how to find the equation of the perpendicular bisector. I hope you've understood, and I thank you very much for watching.